Hello, welcome to a new video. In this video, we are going to see an important result on the continuity of functions defined on topological spaces. Here we consider two continuous functions, f and g. The first function, f, is defined from x to y. X and y are topological spaces, and the second function, g, is defined from y to z. Then we consider the composition of the functions g composition f, which is denoted here by g dot f, g composition f, and you know that this function is defined from x to z. We want to show that this function is continuous. That's g dot f, g composition f, which is different from x to z, is continuous. How can we prove the continuity of a function? If you want to show that a function f is continuous using the definition of continuous functions, you have to consider open sets which belong to the second space. Suppose a function is defined from first space to the second space, then we have to consider open sets, arbitrarily open sets from the second space. If it's inverse image, if the inverse image of that open set is also open in the first space, then we say that the function is continuous. So in order to show that in this case g dot f is continuous, we have to consider open sets in the second space. That second space here is z. So here we choose open sets, arbitrarily open sets from the second space. So let us consider O, an open set in Z. Now we know that O is in Z. Since O is in Z, you have to consider the continuity of the function g. You know that the function g is continuous. Since g is continuous from y to z, and also the open set O is present in Z, using the continuity of the function g, we can say that g inverse O. See, O is in Z, so g inverse O is is open in y. G inverse O is open in y. Since g inverse O is open in y, then using the continuity of the function f, which is different from x to y, see, g inverse O is in y. That's the second space of the function f. Then since f is continuous, f inverse of g inverse of, when f inverse is applied on that open set, we get that f inverse of g inverse of O. So that's here, f inverse of g inverse of O, that's open in. We get that using the continuity of the function f, we get that this set, the set f inverse of g inverse of O, is open in X. So thus we have the steps. First we consider an open set O in Z, and then using the continuity of the function g, we get that g inverse O is open in y. Again, since f is continuous, applying f inverse on that open set which is present in y, we get that f inverse of g inverse of O, an open set in X. Then you can write that f inverse of g inverse of O, we can write that it as g dot f, the whole inverse of O. See, f inverse of g inverse of O is equal to g dot f of f, the whole inverse of O, and we get that we have just proved that that set, this set is open. Therefore g dot f, the whole inverse of O, is also open. It's open. Hence we get that g dot f is a continuous function from x to z. Okay, thank you for listening.